Hello everyone, welcome back to Sir⁶ channel. For today's video, we will discuss the derivatives of trigonometric function together with chain rule, product rule, and quotient rule. Let's get started. Okay, so let's start with example number 1. So example number 1, differentiate y equals sine to the power of 6 of 4x squared plus 2x minus 1. So take note, we can rewrite this as the quantity of sine of 4x squared plus 2x minus 1 raised to the power of 6. So we have now the outer function, the inner function, and of course, the angle. Okay, so we're going to get the derivative first for the outer, followed by the inner, and then lastly the derivative of the angle. Okay, so applying chain rule, starting with the derivative of the outer function, so we bring down 6. Okay, so 6 the exponent, and then we subtract 6 by 1. So instead of writing it in this manner, we can also write it in this way, so that it is easier to read the given. So we have here sine to the power of 6 minus 1 of 4x squared plus 2x minus 1, and then followed by the derivative of the inner. So the derivative of sine is cosine. So that's why we have here times cosine of 4x squared plus 2x minus 1. Just copy the angle. And then lastly, of course, the green label here, we need to get the derivative of the angle. So for the derivative of the angle, so we have 4 times 2, which is just 8. Then we have x to the power of 2 minus 1, which is just x. And then of course, the derivative of 2x is 2 times 1, which is just 2. And lastly, the derivative of negative 1 is just 0. So that's why we do not write 0 anymore here. Then we distribute or rearrange. So basically, we write the algebraic expressions, constants, at the leftmost part. So we distribute 6 to 8 and 2. So we have 8 times 6 and 2 times 6, which is just 48x plus 12. And then we just copy. So of course, 6 minus 1 is 5 here. And we have the final answer. Let's proceed to the next example. Example number 2, differentiate y equals square root of cos²x. So take note, we can rewrite square root as an exponential fraction of 1/2. So we have here cos²x raised to the power of 1/2. So we can now apply power rule. So once again, we have the outer function, the inner function, and lastly the angle. So let's start with the derivative of the outer. So we just simply bring down 1/2, subtract 1 from the exponent, 1/2 minus 1. So again, we can rewrite it in this manner. Copy the angle here. So this is the derivative of the outer, and times the derivative of the inner. So take note, the derivative of cos² is cos² cotangent. So that's why we have here cos² 2x cotangent to x. And of course, according to the formula, negative. It's negative cos² 2x cotangent to x. So just view the previous video. There are examples for each formula. Formula for the derivatives of trigo function. Okay, then next we have the derivative of the angle. So the derivative of 2x is simply 2. So we can rearrange. So take note, we can multiply the constants here. 2 and 1/2 is just 1. And we have here a negative sign indicating there's a negative 1 here. So we can rewrite negative at the leftmost part. So that's why we have it here. And then of course, 1/2 minus 1 is negative 1/2. And then we just copy cos² 2x and cotangent 2x here. So this is not yet the final answer because we can still combine cosecant negative 1 to the power of negative 1/2 2x times cosecant 2x. So we can add their exponent. So there is an invisible 1 here, remember? So we have negative 1/2 plus 1 is just positive 1/2. So we have negative cosecant positive to the power of positive 1/2 of 2x cotangent 2x. Then we can rewrite again. So instead of having a fractional exponent, so take note this is square root of cosecant 2x. So we just write it here. So the final answer is negative cotangent of 2x square root of cosecant 2x. Example number 3. Differentiate y equals cos²x tan x. Okay, so in this scenario, we're going to use product rule, and as a review, we have here the formula, derivative of u times v, where u are the factors. So we will have u times the derivative of v plus v times the derivative of u. So in this scenario, our u is cos²x, and then our v is tan x. So we just follow the formula. So we will write u first. So we have cos²x and then times the derivative of v. So derivative of tangent is secant squared. So we have times secant squared x. Then of course times the derivative of the angle. Derivative of x is simply 1. So that's why there is a times 1 here. And then plus v du. So we have tan x and then times the derivative of u. So derivative of cosine is negative sine. So that's why we have here negative sine 3x, and of course times the derivative of the angle of cos²x, which is 3x. So derivative of 3x is 3. And then we just rearrange. So we will have this here, cos²x secant squared x minus, it's minus because we have a negative sign here. So we just rearrange. And then of course we have the constant 3 here. So we have negative 3 tan x sine 3x. This is the answer. Let's proceed to example number 4. So example number 4, we have here y equals cos²x sine 2x. And similar to example number 3, we're gonna apply product rule because we have factors. But take note, cos here is squared. So there is an exponent. If you have an exponent, you are going to apply chain rule within product rule. So let's start the solution. So cos²x is u, sine 2x is v. So we just follow the formula. We write first u, which is cos²x. So followed by the derivative of sine 2x. So derivative of sine is cos. So that's why we have here cos²x. And then times the derivative of the angle, which is 2. And then plus, then we have v. v is sine 2x. Then here, du, we're going to apply chain rule. So we have the outer function, which is squared. So we just bring down 2. Then subtract 1 from the exponent. So that's why we have 2 minus 1 here. And of course, copy the angle. That's for the outer. For the inner, it's the trigo itself. So the derivative of cos² is sine x, negative sine x rather. So it's negative sine x. So we have negative sine x. That's the inner. And lastly, we have the angle. So angle is x. Derivative of x is simply 1. Okay, so then we rearrange. So rearranging this, we will have cos²x, cos²x. And then for the second term, of course, we have a negative sign here. So 2 times negative times 1 is just negative 2. And then we just copy sine 2x, cos x, and sine x. Of course, this is cos x. It's because 2 minus 1 is just 1. We do not write anymore the exponent 1. So this is the derivative of our given. Example number 5. So here, we are asked to differentiate y equals 1 plus sine x all over tan x. So this is now applying quotient rule. So just to review, quotient rule, we have here u over v. where u is our numerator, v is the denominator. So the derivative of that is just v du minus u dv over v squared. So in this scenario, our u is 1 plus sine x, our v is tan x. So following the formula, we write first v is tan x, and then get the derivative of u. So take note, our u is a binomial, so we will get the derivative of each term. So derivative of 1 is 0, derivative of sine is cos. So that's why here we have times the quantity, so because it's being binomial, so we have 0 plus derivative of sine x is cos x times the derivative, of course, of the angle x, which is 1 here, minus u dv. So we just write 1 plus sine x again with the parenthesis because this is binomial, 2 terms, and then times the derivative of v. So derivative of tan is secant squared, and of course times the derivative of its angle, derivative of x is 1, all over we have v squared. So this becomes tan squared x. So we just need to distribute. So of course this is 0, so we just need to distribute tan x to cos x. So that's why here we have tan x cos x. And then here, take note, we have secant squared x, and this is just 1, so just never mind 1 here. So we distribute secant squared x to 1, which is secant squared x. So secant squared x times 1 is secant squared x, and then secant squared x times sine x is just sine x secant squared x. So don't also forget to distribute the negative sign here, so that's why we have a negative secant squared x here, and of course this plus here becomes negative, so that's why this is also negative here. So this can be the final answer. So take note, you can still simplify this further using Trigo identities, but for the purpose of this lesson, we just need to know how to get the derivative, and not the topic is not about simplifying the answer. So this can be the final answer. Let's have the 6th example. So for example number 6, let's have another rational function containing trigonometric functions. So we have y equals cos 3x all over sine squared 2x, and again we use quotient rule. So our u is cos 3x, our v is sine squared 2x. So we write first sine squared 2x, then get the derivative of cos 3x. So derivative of cos is negative sine, so that's why we have here negative sine 3x, and of course the derivative of the angle 3x is just 3, minus v du. So v is u dv, okay, u is cos 3x, and then here we have exponent, so we will use chain rule again. So we bring down 2 and then copy and then subtract 1 from the exponent, so 2 minus 1 here. Okay, so that's the outer function of sine squared 2x, derivative of the outer function, then times the derivative of the inner, so the derivative of sine 2x, derivative of sine 2x is cos 2x, and lastly the derivative of the angle, which is just 2. So we have here all over v squared. So take note, this is sine squared 2x already, so if we raise this to the power of 2, we just multiply. So we have 2 times 2, so that's why we have sine to the power of 4 of 2x. Rearranging this, so again we have negative here and 3 here, so we have negative 3 sine squared 2x, so just copy sine 3x, and then we have 2 times 2 here, of course, so we have 4, and then just copy cos 3x, so sine to the power of 2 minus 1 is just sine, so that's why it becomes sine 2x here, and then just copy cos 2x all over sine to the power of 4 of 2x. So take note, there is a common factor in the 2 terms of the numerator, so both contain sine 2x. So we have here sine 2x here and also here. So we can factor out sine 2x. Okay, So what remains inside, or in the factors, or rather the terms, is we have here negative 3 sin²x sin3x minus 4 cos3x cos2x. So we can cancel out sin2x, and this becomes sine cube 2x in the denominator, and we just rewrite. So for this, the final answer is just negative 3 sin2x sin3x minus 4 cos3x cos2x all over sine cube 2x. So that's it for today's video. We're done with the chain rule, product rule, quotient rule of trigonometric functions. For the next video, we will discuss the chain rule, product rule, quotient rule of exponential and logarithmic functions. So see you in the next video. Bye bye.